Hello, good morning. This is Luis Perez from BGT81 F. Me and Lance Mendoza now we're going to report about the history of nanotechnology. This report is all about the history of nanotechnology from 2,000 years ago until 2000 in a modern era. So, first is the 2,000 years ago. So, people, Roman and Greek people are to sulfide nanocrystals to dye their hair, because in that time cosmetics was rarely found, even though the technology was not powerful before, like in this time. In their time, dyeing hair is a kind of formulating a date between Greek and Roman. So that is why how important the dyeing of hair in their time, and they use the sulfide nanocrystals to make it. So after the 2000 years ago, of course, the next is the 1000 years ago. So the gold nanoparticles is used to make a different kind of colors in stained glasses in windows. The example in here is the glass that we can see on some churches, some Catholic churches. As you can see on their windows, it designed by the different colors, but it still has a one design. So next is the 1959, or There's a Plenty of Room at the Bottom by Richard Feynman. So on December 29, 1959, physicist Richard Feynman gave a radical lecture at an American Physical Society meeting at Caltech, and he entitled it as There's a Plenty of Room at the Bottom. So Richard Feynman suggests that it should be possible to make a machine at a nanoscale that arrange the atoms the way we want, and also to do a chemical synthesis by mechanical manipulation. So after 1959, next is the 1974. It is 1974 by Taniguchi, wherein Dr. Nori Taniguchi is a Japanese scientist coined the term nanotechnology in 1974. And he also defined nanotechnology as the processing of separation, consolidation, and deformation of materials by one atom or one molecule. So the term nanotechnology was coined by Taniguchi in 1974, but its conceptual foundation was established after the famous lecture on There's a Plenty of Room at the Bottom by Nobel of Richard Feynman on December 29, 1959. So the nanomaterials on this here are very small size, and the large surface to volume ratio of the nanomaterials leads to a significant change in their physical and chemical properties. So recently, nanomaterials have been utilized as carriers by attaching the drug molecules and delivering them into target tissue, more specifically in a controlled manner. So after Taniguchi in 1974, next is 1981, and it is the scanning tunneling microscope, or the STM. So the scanning tunneling microscope, or STM, images material. It is a surface at atomic level. It was developed by Gerd Bining and Heinrich Roscher at the IBM Research Laboratory in Rashikon, Zurich in 1981. They were awarded the Nobel Prize in Physics for this invention in 1986. So for the STM to work, the measured sample must conduct electricity, or it might be a metal or semiconductor. So the STM particular useful for studies in the field of nanoelectronics. So the scanning tunneling microscope, or STM, works by scanning a very sharp metal wire tip over the sample surface. So by bringing the tip very close to the surface, and by applying an electrical voltage to the tip of the sample, the surface can be imaged down to the individual atoms. And the rest of the years will report by Lance Wendell Sestina.
1985 Buckyball, scientists at Rice University and University of Sussex discover. Buckyball, developed by NSF-funded researchers in 1985, are a form of carbon-composed cluster of 60 carbon atoms, bonded together in a polyhedral or many-sided structure composed of pentagon and hexagon, like a surface of a soccer ball. So, who invented the buckyball? Buckminster fluorine was discovered by Sir Harry Kroto of University of Sussex and Richard Smalley and Bob Carl of Rice University in 1985 during a joint research project. Their discovery led to a Nobel Prize in 1996. Next is 1986 Engine Operation. So the book features nanotechnology, which Richard Freeman had discussed in his 1959 speech. There's plenty of room at the bottom. Drexler imagined a world where the entire Library of Congress can fit on a chip the size of a sugar cube, and where universal assemblers, tiny machine that can build object atom by atom, will be used for everything from medicinal robots that help clear capillaries to environmental scrubbers that clear pollutants from the air. In the book, Drexler proposes the gray goo scenario, one prediction of might happen in molecular nanotechnology, were used to build uncontrollable self-replicating machine. In 1989, IBM logo made with individual atoms. IBM and Atom was a demonstration by IBM scientists in 1989 of a technology capable of manipulating individual atoms. A scanning tunneling microscope was used to arrange 35 individual xenon atoms on a substrate of chilled crystal of nickel to spell out the three-letter company initialism. Next is 1991 carbon nanotube discovered by S. Lijima. So, carbon nanotube are large molecules of pure carbon that are long and thin, shaped like tubes, about 1 to 3 nanometers. 1 nanometer is equal to 1 billion of meter in a diameter and hundreds to thousands of nanometer long. As individual molecule nanotube are 100 times stronger than steel and 1/6 its weight. What are carbon nanotubes used for? So, as of 2013, carbon nanotube production exceeded several thousand tons per year, used for application in energy storage, devices modeling, automotive parts, boat hulls, sporting goods, water filter, thin film electronics, and coating, and actuators and electromagnetic shield. Next is 1999 Nanomedicine, first nanomedicine book by R. Freitas. Nanomedicine is the medical application of nanotechnology. Nanomedicine ranges from the medical application of nanomaterial and biological devices to nanoelectronic, biosensors, and even possible future application of molecular nanotechnology such as biological machine. What is nanomedicine used for? So, the application of nanotechnology of medical purposes has been termed nanomedicine and is defined as the use of nanomaterial for diagnosis, monitoring, control, prevention, and treatment of disease. So, what is nanomedicine and how it works? Nanomedicine is the application of nanomaterial for nanoparticle to medicine. Nanoparticle can be engineered and designed to package and transport drugs directly to where they're needed. This targeted approach means the drugs cause most harm in the particular and intended area of the tumor they are delivered to. Lastly, in year 2000, National Nanotechnology Initiative launched. So, the National Nanotechnology Initiative is a U.S. government research and development by R&D initiative. The NNI participating agencies work together to advance discovery and innovation across the nanotechnology R&D enterprise. Who participate in National Nanotechnology Initiative? So, when was National Nanotechnology Initiative launched? In year 2000, President Clinton launched the National Nanotechnology Initiative in NNI to coordinate federal R&D efforts and promote U.S. competitiveness in nanotechnology. Congress funded the NNI for the first time in year 2001.
Hi, good afternoon. I'm Donna together with Shara. We are going to discuss about the developments in nanotechnology. So, actually, there are a lot of developments in nanotechnology, but we only choose the six most innovative nanotechnology. So the first one is the health drug delivery. So today, cancer patients have three treatments options: the surgery, chemotherapy, and radiation. So those three varies in methods, but their goal is to eradicate the targeted cancer cells. So nanoparticles delivers medicines like chemotherapy straight to the tumor. So, hindi mo na nila i-release yung medicine until na makarating sila dun sa tumor. So, tsaka lang dun i-release yung gamot. So, this stops the drugs to damaging healthy tissues around the tumor. Kasi, pag na-damage yung mga tissues around sa tumor, there's a possibility na may mga side effects na mga sobrang lalang side effects. So, the next one is the agriculture, crop protection, and livestock productivity. So, currently, the world population is growing at 1.13% per year with an estimated 7.4 billion people in the world. So, pinipredict ng mga experts na madadagdagan pa yung population to 90 billion by 2050. So, that means na mag-i-increase sa food demand. So, nanotechnology provides agrochemical agents wherein they improve the crop productivity and nire-reduce yung pesticides na mga ginagamit. So, another thing is yung mga nanosensor, which is ina-identified yung mga diseases and residues of agrochemicals dun sa crops. And the next one is the diseases or early detection, wherein scientists uses nanoparticles to raise a warning, since these nanoparticles carries several of peptides. In theory, it should send a numerous of biomarkers to detect diseases or cancers. So, madedetect dito yung Alzheimer and cancer, and this allows potential treatment and to cure.
Hi, I am Charmaine and I'm here to add what Donna has reported already about nano development, and adding to that, environment water cleanliness. Oil spill can be catastrophic for oceans, rivers, and wildlife that resides within it. Conventional methods of cleaning spillages are inadequate, and although still in their infancy of nano-based solutions, show great promise as an alternative means of tackling the cleanup operation. Nanotechnology-based solution can contribute to the long-term quality and availability and visibility of water in several ways like treatment and remediation, sensing and detection, and lastly, pollution prevention. There are a variety of ways in which nanotechnology-based solution can help to improve the long-term quality, availability, and viability of water resources. Nanotechnology may result in the development of a new generation of nanomembranes for separation, which will allow a higher water purification and desalination, as well as more effective methods of eliminating, decreasing, or neutralizing water pollutants. Iron nanoparticles are being used to remove organic solvent from groundwater, which is practical water cleaning use that already been proven. Yeah. The nanoparticles disperse the through the water and decompose solvent without the need to pump water out of the ground, making the method more effective and less expensive. Nanotechnology based solutions can also remove radioactive waste. Titanate nanofibers act as good absorbent to remove radioactive ions such as cesium and iodine from water. Next, let's move on to number 5, pollution, cleaning the air. Carbon dioxide or CO2 is a major environmental issue. Large volumes of this greenhouse gas have been contaminating the atmosphere and driving the climate change since the Industrial Revolution. Global warming causes polar ice caps to melt and many low-lying areas to vanish. Utilizing renewable energies is already reducing the amount of CO2 released into the air. However, there is a need to filter CO2 from waste gases for capture and storage if there is no alternative to burning fossil fuels. Current methods to separate CO2 from waste gases are expensive, utilize chemicals, and are not competitive enough for large-scale application. However, membranes constructed from nanomaterials could work in the same way at fraction of the cost without additional compounds. Nanotech offers a numerous opportunity for environmental technologies. There are already many success stories in sensing and monitoring selective adsorption and nanomembranes. However, we must be careful to balance the need of the environment and the selectivity and stability of the nanotechnology we choose. Lastly, in nano development, technology, information, and communication. Number 6. Information and communication technology is a significant and quickly increasing industrial sector that experiencing fast growth in terms of new products and services. Making the move from traditional to nanoscale electronics has resulted in numerous advancement in technology. Nanotechnology has brought about sea change in the field of information and communication technology. Ultra-integrated optoelectronics combined with powerful wireless technology as low-price, mass-market products. Ultra miniaturization, the design of innovative sensors, the production of cheap and powerful polytronic circuits, novel system architecture based on nanotechnology for future DNA computing, which will serve as an interface to biochemical process, and quantum computing, which can solve problems for which there are no efficient classical algorithms, are all being researched and developed. Quantum crypto- cryptography for military and intelligence application is becoming more prevalent as a result of the development of nanoelectronic components.
Good day everyone, my name is Stephen Albendo and I will be talking about application of nanotechnology. So, nanotechnology has been applied in many fields such as medicine, information technology, energy, industry, household, and environment. So ngayon, tingnan naman natin ang application ng nanotechnology sa household. So, sa household, yung mga cutlery, surfaces, fridges, door handles, pet balls ay meron ng mga silver nanoparticles na nakakatulong upang maging heat resistant and self-cleaning. Sunod naman ay ang application ng nanotechnology sa environment. So magandang example nito ay yung water purification. So sabi ng mga scientists and engineers, malaki talaga ang tulong ng nanotechnology sa pag-improve ng water purification. So marami pang tulong ang nanotechnology sa environment tulad ng contaminated soil treatment, remediation sensor, and energy storage. So next is ang application ng nanotechnology sa medicine. So sabi dito, one application of nanotechnology in medicine currently being developed involves employing nanoparticles to deliver drugs, heat, light, or other substances to specific types of cells. So, nakakatulong daw to para ma-reduce yung damage to healthy cells in the body and allows for earlier detection of disease. So, ayun ang application ng nanotechnology in medicine.
Good morning. Good morning, classmate, and good morning, sir. My name is Dibert N. Moreno. Application of nanotechnology in cosmetic. Nanotechnologies allow enhanced properties in many areas of interest to the cosmetic industry, including UV protection, deeper skin penetration, and improved hydration. Nanotechnology also allows the packaging of many ingredients in semi-soluble packets that break down as the product is being applied, not before. Transportation. Nanotechnology is applied to car body parts like emission, chassis, tires, automobiles, interior, electric, etc. Body part application including paint coating, lightweight parts, self-cleaning, and scratch-resistant nanopolymers. The main advantage of applying nanotechnology in automobile including providing lighter and stronger body parts to enhance safety and fuel efficiency, improving fuel consumption efficiency, and therefore achieving a better performance over a longer period. Food industry. Nanotechnology may revolutionize the food industry by providing stronger, high-barrier packaging materials, more potent antimicrobial agent, and a host of sensors which can detect trace contaminants, gases, or microbes in packaged foods. That's all. Thank you.
So let us move on and let me discuss to you guys the issues and concern or what are the effects of nanotechnology in organisms. So first or number one is the absorption and toxicity. Nanoparticles can pass through different cell membranes of mammalians and be absorbed in them, and their absorption rates depend on their size. So, if the nanoparticles can pass through the different cell membranes and being absorbed by them, it can cause toxicity or toxic reactions, specifically in the part of the cell called mitochondria. So, another effect on organisms is that the carbon black particles, or we can simply distinguish as a nanoparticle, can find their way deep in the lungs and can cause toxic effects. So, especially to those people who are used to work in gas, coal, and asphalt industries. Number two is the absorption of environmental under environmental conditions. So most toxicology studies of nanoparticles have been performed on mammalian cells. In these studies, the nanoparticles were exposed to the cell culture media that contained protein and other biological compounds. So here, there are two types of cells, the prokaryotes and the eukaryotes. So back then in senior high, you've learned about the difference between the two. The prokaryotes, such as bacteria, and the eukaryotes, which are the cells that the human have. Going back, um, the cellular surface of the prokaryotes have a protective barrier that prevents the absorption of nanoparticles, since there are no mechanisms that exist for them. Yeah. On the other hand, the eukaryotes, unicellular or multicellular, has its own mechanism, making the situation different when it comes to the absorption of nanoparticles.
So, next is nanoparticles in outdoor spaces. So, since nanotechnology produce materials of various types at nanoscale level, nanoparticles is one of the materials that include particulate substances which have one dimension and less than 100 millimeter at least. So, according to some study, people are at risk of adverse health effects caused by exposure of nanoparticles. So, why? It is due to their special physical and chemical properties. Nanoparticles readily enter indoor and outdoor workspaces and are distributed throughout these spaces. So they can cause biochemical damage by creating some reactions in the cells of the human body. And other hazards are such as DNA damage, genotoxic effects, damages to organs and tissues in human body. It can also damage our lungs and can even cause heart problems. So there are still some study going on about the hazards and risk about nanoparticles, but other studies said, as per Nina said earlier, it can also damage the growth and yield of crops and other negative impacts in our environment. So, uh, nanoparticles has many uh, bad side effects in our environment, in our health.
Good day, everyone. I'm Eliza Hilario, and the topic that I will going to discuss is nanotechnology advantage in society. Number one, manufacturing advantage of nanomaterials. Nanotechnology is already making new materials available that could revolutionize many areas of manufacturing. With nanotechnology, we can create unique materials and products which are stronger, lighter, cheaper, durable, and precise. Industrial computers, which made with nanomaterials, can become million times faster and a million times smaller. Automatic cleanup and manufacturing at very low cost or no cost at all. Number 2 is energy and electronic advantages. Nanotechnology may transform the ways in which we obtain and use energy. In particular, it's likely that nanotechnology will make solar power more economical by reducing the cost of constructing solar panels and related equipment. Energy storage devices will become more efficient as a result. Nanotechnology will also open up a new methods of generating and storing the energy. Number 3 is medical benefits. Nanotechnology has the potential to bring major advances in medicine. Nanobots could be sent into a patient's arteries to clear away blockage. Surgeries could become much faster and more accurate. Injuries could repaired cell by cell. It may even become possible to heal genetic conditions by fixing damaged genes. Nanotechnology could also be used to refine drug production, tailoring drugs at a molecular level to make them more effective and reduce side effects. It can also end of the illness like cancer and also heart disease. And also universal immunity in AIDS and also in flu. And the last one is body sculpting, changing of appearance. That's all, and thank you.
Good day everyone. I am Justin Tabanan, and let's now discuss about the disadvantages of nanotechnology in the society. The common challenges related to commercializing nanotechnology are high processing costs, problems in the industrial production, and concerns about public perception of environmental health and safety issues. The governments across the world should form common and strict norms in monitoring before commercialization and bulk use of these nanomaterials. Disadvantages also include potential dangers to humans and environments. Particles on a nanoscale can cause toxic effects in humans. They are so small, they can have the potential to cross the blood-brain barrier, which could cause mass poisoning or unwanted neurological effects. Loss of manufacturing and agricultural jobs is also included in the list of disadvantages due to the possible loss of jobs in the traditional farming and manufacturing industry, since nanotechnology can provide faster than the normal production of people. They can produce up to 2 times or 3 times more than a manpower can within a day. Another one would be economic market crashes related to the potential value of oil to more efficient energy sources in golds or diamonds, materials that can be reproduced with molecular manipulations. And another one will be also accessibility of weapons of mass destruction and also improve atomic weaponry. One fear is manipulating particles to intentionally cause physical harm to one or more persons. Especially dangerous is the prospect of a terrorist applying this technology to create small, undetectable biological or atomic weaponry. And presently, nanotechnology is very expensive and developing. It can cost you a lot of money. It is also pretty difficult to manufacture, which is probably why products made with nanotechnology are more expensive.